So guys, yesterday we have completed beautiful year question. I think this one. Uh, yeah, this question. Let it load. This is right wherein there's a year that's given. We find the next year where we have all the characters unique. So that's what we solved yesterday. It was pretty straightforward. Let me just go through the solution once. Yeah, we started solving questions in Python because I'm not able to recall C++ for some because it's been a long time that I've worked on C++ code. So Python is straightforward for scripting and anything related to scripting and problem solving, right? I know there is performance trade-off and everything, but I think most of it is fine for scripting and everything. And I made sure we are minimizing as many inbuilt libraries as possible, so that way we are making sure uh, all the bigger notation, what do you say, man? All the space and time complexities are maintained. Yeah. So cool. Let's get started. I'll just walk you through this question. What we have done is we take the input here. We increment it because we don't want this year. We don't want to consider the input here because they are explicitly asked. We said that it's strictly greater than y, right? Y is basically the input that they give. So strictly greater than y means we have to increment it by one. Let me just, yeah. So what we do is we maintain a dictionary here, right? Wherein let me just connect my mouse real quick. Okay, cool. So we maintain a dictionary. We go through the whole input string here, and then track the character. This thing, right? Then we set the counter as 0. So basically, this counter will check how many unique numbers we have, right? Irrespective of what are the number of characters and everything. If since they have mentioned that it's between 1000 and 9000, we can be sure that it is a 4-digit number. Even the result will be a 4-digit number, so we can uh, add a condition saying if the number of characters in the dictionary you are number of unique characters in the dictionary is equal to 4, then just print the unique number and just exit from the program. This is the whole logic here. So we are tracking the number of occurrences of the character. We go through all the values here and we check for the unique ones and increment the counter. If it's 4, we just print it, exit out of the program. Else we just increment the number, we go to the next number, do the same thing until we get the number itself, right? So that's what we did. We were able to solve it as well. You can see the result here. So yeah, we are going for the next question, that is lights out. I haven't read this question, so we'll solve it together now. Lenny is playing a game of 3 by 3 grid lights. In the beginning of the game, all lights are switched on. Pressing any will toggle, and or its side adjacent lights. So if we turn on this one, all the side adjacent, this one and this one is okay. If we toggle this one, which means if we toggle 1 to 0, this and this will become 1. Okay, 1. And likewise, if we go here, this and this should become 1. Then wait, no, pressing all areas to play. The code is to all the lights off. We consider the toggling as follows: if light was switched on, we switched off It was switched off, then it will be switched on. What? Okay. Uh, hmm. Switch what? Hmm. Yes, spent some time to no, by now she has passed each light in a certain number of times. Given the number of times each light is pressed, you have to print the current state of each light. Hmm. It consists of three rows. Each row contains three integers, each between 0 to 100 inclusive. The jth number and ith number is the number of times the ith light and the jth row of the grid is pressed. Given the three lines, each containing three characters, j and ith line is one, and if and only the corresponding light is turned on, switched on. Otherwise, it's off. Okay. Okay. Let's let me try to read this once again. It is playing a game on a 3 by 3 grid lights. Hmm. Beginning of the game, all lights are switched on. Hmm. Pressing any of the light will toggle and all the adjacent lights. Okay, since it's a 3 by 3 grid, which means nine possible iterations. Number of times the hmm, okay. So given the number of times each light is pressed. Yeah, state the light is switched off. Okay, each row containing I this thing. Initially, what's happening here? Pressing all the lights will toggle it and all adjacent lights. The goal of the game is to switch off all the we consider the following. Toggling as far as if the light was switched on, then it will be switched off. It was switched off and it was switched on. Spend some time playing with the grid, and by now he has pressed each light a certain number of times. Given the number of times each light is pressed, you have to print the constant of each light. Hmm. All the lights are switched on. Okay, cool. Which means 1 is odd, 0 is even. Hmm. This is even, which means these and these will be off. No, this will be off, but then, oh, we can do one thing. Number of times it is off. Hmm. Okay, what we can do is every time it is on, we increment the adjacent ones by 1. Okay, which means now initially we'll keep a record of all the. Oh, I understood the problem. So what we'll do is we'll create another array wherein we store all the we'll create another array of 3 by 3 this thing, right? Which will be something. Okay, first let me just pull in this question. One second. Why is this not working? Give me a second. Let me select the window. Cool. Hmm, yeah. taking time for some reason. I think this Chrome extension is bugging out, I guess. Give me a second. Cool, let me set up really. Okay, so let me pull in pull in this problem now in Python. Yeah. So what we'll do is we'll take the input of this array. So how do we do that? What we'll do is we'll create a x. Is this how it's done? No. List of list, right? Cool. For I in range of 3, for j in range of 3. We know that it will be 3 by 3 grid every single time. So what we'll do is y equal to int of input x of I j equal to y. So this is the x we have. We all will also have temp result, which will be a array of array, right? For I in range of 0, j for not 0. What the hell? Let's say I don't know if this works or not. I'm just in a range of 3. Let's see if this works. This is the first time I'm doing list comprehension within the list comprehension. uh, Anyways, let's just first print out this result. Print a result. Okay, let's try to print this up. Oh cool, this works. Hey, no, no, the fuck. Okay, so this thing is not working. So because it's taking a line, this thing, so 3 lines will just go here. Do this int of input is not possible. We'll take the input. Input will split. Then we'll do a list comprehension of this split, I guess. Int of I for I in x of I. Okay, so x of I equal to y. If I do this, we'll get 3 arrays, I guess. And let's also print x once. Print x, then print result once. What's happening? X of I equal to, it's not working. It's not a board. I equal to 0, 0. Okay, this is why. Index out of bound. Cool. Let me just. Why is that for? Okay. Int of I or int of I for I in input dot split. Oh, is this? Oh, okay. No, it's I. It's not I. What the fuck? Push, right? Yeah. why not push or whatever? Wait, x dot extend append, and this Python x dot append. Yeah, hmm. This is also working, and result is not working. Huh? Okay, means for in range of 3, for change range of 3 is not working. Okay, is thrice. If I do this, then what? Times times 3. Will this work? Curious, man. No. Hey, wait. This worked, I guess. 0 1 2 0 1 2. Oh man, this should be 0, not J. Yeah, you have a 0 and a input ka value. Array should have both. Anyways, so we have x and this thing. What we'll do is we'll simply go and check if the value is even or not. If it's even, no. If this is 1, right, odd, simply increment this thing. We'll go to the input itself and go here. Even here we have only switched toggled it one time, so we'll increment this and this. Based on this, if it's a even number, then it's a 0. No, so 0, then what? Wait, is there explanation for this? No. Let's go here. It's a 1, which means this and this will be 1. Mm, all the edges in that axis are what? Wait. Uh, all adjacent side lights. Yeah, if I toggle this one, this is the first switch on, then all of them will switch off. Okay, cool. So okay, let me just code the same thing here. If I go 1 0 0 initially, 0 0 0 0 and 0 0 1, right? Initially I'm toggling this as this will be switched off, but these two will switch on, right? Similarly these two will be switched on. Then I come here, I'll try to switch this off, which means this will be on, this will be on. No, man. Okay. Oh, this will be even, right? Wait, this will be 2 then, I guess. Yeah, this will be 2, which means the even number, this will be off, containing jth the character only will be switched on, otherwise it's a 0. If it's on, yeah, I'm turning this off, this is on, this is off. Initially all of them are on. Turn this thing is off, on, on, off, this is on, this is off, on, this is off. What the fuck, what's this, man? Given the number of times each light is pressed, you have to print the current state of each light. Even means it's a 0. It's also 0. It should be this. Adjacent ones. Let me just Google what the fuck is adjacent. Adjacent math. Paint. All of them, man. Even this will be on. No, let me just try again. It's the problem again. Yeah. So this was 0 0 0 0 0 0 0 1. right? So once I turn off this one is 1, this one is 1, and this one is 1. So initially all of them were on. Okay, all of them were 1. If I turn off, this is 0, this is 0, this is 0. Hey, fucking, this is so easy, man. Instead of 0, initially all of them are 1, right? I'll just go here, and every single time I find a number there, every time I see a number, I'll just, if it's a 8 times this thing, it will be 0, obviously. No, it will be 1. I just have 1 0. Mm, okay, I need conditions here. So what we can do is, this is 1 initially, for I in range of x, x is 3, for j in range of 3 again, if so this is my input, but initially I have the result, I have 1, all of them are on. Whenever I turn off, I also turn off the all the 4 sides of this thing, right? Which means it's out. If it's a negative number, I'll simply ignore it. So I'll go if I minus 1, no, what I'll do is I minus 1, j minus 1, I plus 1, j plus 1. I plus 1 greater than 0 and j minus 1 greater than 0, else I'll simply ignore that. Okay, so result to x of, no, result of I minus 1, j minus 1 equal to, how many times was that? Initially it was this thing, simply increment it later on. If it's a odd number, initially it was odd number, if it's a odd number again, it's odd, else it's 0. I'll simply increment this thing by plus whatever the x value is, x of I minus 1, j minus 1, no, x of I, j of I. Similarly for all the 4 cases, right? We'll do the same for all the other cases. I plus 1, if I plus 1, but it should be, for I plus 1 it should be less than 3. J plus 1 should also be less than 3. No, I is this one, right? I 1, 2, 3. Yeah, should be less than 3. Something is going negative, then it should be greater than 0, greater than minus 1, greater than or equal to 0. Is will be inputted, we'll iterate through it, and if it's a even number, then same thing, j minus 1 greater or equal to 0. Last case, hey, 1 greater than or equal to 0 plus 1 less than 3, and the actual one, this one will be there. The result of I j equal to result I j plus x of I j. So for I in the range of 3, in range of 3, the result of I j mod 2 fits there will print 1 with a space, else will print 0 with a space, right? This is the print for the next line. Let's see if this works. Oh, and end equal to this one, because it shouldn't go to the next line. Let's see. No, it's not correct answer. Hey, this print should be here. I think I don't need a extra space. See, expected this thing, I got the value as this thing. So which means modulo 2 fits there. No, right, wait. Oh, I'm incrementing same bull. Oh, okay, -1. This should be plus. This should be plus. This is plus, this is minus. Okay. Plus, I just copy pasted the same. This thing. Okay, this should work. Nope. Shucks. What's the issue here? I'm incrementing this thing. So if I'm incrementing 8 here, it should also increment 8 here, here, and here. What am I doing? When I'm going below j, I, increment j, increment I. I'm going diagonal. That's why this is the issue. So okay, we'll do one thing instead of and. Simply put j. This is j, let this way as it is. Then we'll go for j. Yeah, for adjacent the x will be same and j will change. Yeah. Yep. See, this was for adjacent ones we should only increment or decrement either one of the axes, right? If we are decrementing both the values, then it's going diagonal instead of going adjacent. Yeah, so let me just try to submit this answer. Let's see. This should actually work. Let's see. Lights out, right? Okay, we'll go for okay, so submit and wait for the answer. Let's see. It is accepted. Nice. Let's Python. Let's see. Let's talk about space and time complexity. For space complexity, it's 9, which is a constant. Since it's a 3 by 3 grid and it won't increase If we change the test case or whatever number of test case and everything, it will be constant, so constant space. And this thing also is constant, I guess, which is 9, right? 9 plus 9, 18. O of 18, which is a constant. O of 1, O of 1, O of 1. This is also 3 by 3. It never increases as there is no increase in input. But there is a variable for this. It's between 0 to 100, but then the size of the array is the input never increases. The question itself is a arithmetic type of question, right? So yeah, let's move on to the next one. Okay, word. Pull in the question. Go to Python. Yeah. Oh, this one is very easy, man. Just take. I think we need the ASCII value of this thing. Whichever is majority, that's what it's giving. See, here we have two caps, so we have caps. Three caps, three small. It's a small. Okay. Comes upper case. So it's what? Asa is very upset that many people on the net mix uppercase and lowercase letters in the word. That's why he decided to invent an extension for his favorite browser that would change the letters registered in every word so that it either only consists of lowercase letters or vice versa, only of uppercase ones. At that, as little as possible letters should be changed in the word. Mm, change this one, we'll get this. Yeah, that's what. See, if we change these two, we'll get as little as. The word house must be replaced with house. Equal number of you should replace all with lowercase ones. For example, matrix should be replaced by matrix. So task is to use this given method on one word. Okay, ASCII values. I think we can ASCII table. I think it's 96 to 127 something. ASCII table will go here. To images, grab the ASCII values, and I have no idea how to get the ASCII value of a character in Python. I think we can do that using print char of uh, x. I guess this is how it's done. I'm not sure. Then we convert it to string. Probably, I'm not sure. I have. Is this how it's done? Let's see. Let's try to. No, didn't even see a char. Okay. Oh, Python is weird, man. String object cannot be interpreted as an integer. Wait, what? Then what do we do now? Let's see. I do this. String object cannot be interpreted as a int. How do I convert this to? Acha, it's taking int of x. What do we do now? If I do this, paste in, it will int based in x. How do I convert a convert char to ASCII Python? I think there is a function for this, I guess. Odd of C will return back the character. Oh, so this will convert ASCII to character. Odd will give you the what is odd? Inbox odd. Python reference. Wait. returns an integer representing the code of the character. What does odd mean though? This function is the inverse of char string and unicode for Unicode objects. If Unicode argument is given Python Unicode standard to Unicode, then character correspond. Okay, out of A, out of okay, cool. So this starts with 97, 97 plus 25. What is 97 plus 25? 132. 97 to 132. It's that. Mm, cool. So print will take x equal to input. Will take input. Wait, what the hell? Okay. For I in x, if odd of I, can we do this? 97, no, it is greater than 96 and less than 120. What is that? 132, 33. Then 27 is A, and print 132, correct? 27 plus 25, 132, 132, no, 112 lah. Yeah. 96 plus 26, 122, less than this thing. Print lower I dot lower, no, hey, no, we need to maintain a count as well, no? Upper cases UC equal to, if it's within this, we won't increment. We'll calculate LC. LC equal to LC plus 1. If LC greater than or equal to x dot len of x by 2, then print dot lower, else print x dot upper. What will happen now? Oh my god, Python is so simple, man. What we have done is we are trying to calculate, trying to check whether it's a lowercase or uppercase. We increment the counter of lowercase, then if it's greater than half of the, greater than or equal to half of this thing, will half of the length of the string, if it's that, because they have explicitly mentioned that if half of the characters are uh, if both uh, both the half of the characters are lowercase and uppercase, then we'll set all of them as lowercase itself. All the characters are lowercase, so that's what we have prioritized here. Else it's uppercase, right? So yeah, this should actually work. Let's submit this. Okay, a word. Okay, cool. Submit. It's in queue. So the process length from 1 to 100, which means I don't think this does really matter. As it considers lowercase and process length of 1 to 100. Within 100, it's completely fine. So now let's move on to the next question. ASCII table, it's 96 to 122, 123. Cool. Let's move on to the next one. Word capitalization. Pull in this question here. Yeah, we'll select Python. Cool. Uh, oh, this is a straightforward question, man. Hmm. Is writing a word with its first letter as a capital letter. Your task is to capitalize the given word. Note that during capitalization, all the characters except the first one remains unchanged. Oh shucks. X equal to input and print x of 1, x of 0 dot upper plus x of 1 as it is. Will this work? Damn. Actually, you know what? We don't even need this thing x and all. I guess I can. No. Can you do this in a better way? I don't remember, but I think we can directly take the input and put it directly within this thing. But mm, I'm not sure how it's done. There is a better way, definitely. Instead of doing it, you can directly do it in one line, I guess. Let's see, x dot upper. Do we have another function for this? Uppercase or something? No, capitalize. Oh my god, we have a this thing. Okay, we can do this print input dot capitalize. God bless Python. No. Oh, okay. It is also altering other characters here. Hmm. This won't work. Cool. Okay. We'll submit this. So very simple, straightforward question. No time complexity, space complexity required here. Uh, yeah, it's accepted. No worries. Next one, lucky number. Nearly lucky number. Hmm. Data loves lucky numbers. We all know that lucky numbers are the positive numbers. Was decimal representation contain only the digits, lucky digits for us. So for example, numbers 4774 and 4 are lucky, and 517467 are not. Unfortunately, not all numbers are lucky. Peter calls a number nearly lucky if the number of lucky digits in it is a lucky number. He wonders whether the number n is nearly lucky or not. Okay, if it's a 1, 2, 3, 3 lucky numbers, then it's a no. 1, 2, 3, 4. Okay, these are 7 lucky numbers. We just sum them and we check whether it's a 4 or a 7. If it's there, if it adds up to be 4 or 7, then it's a lucky number. Cool, we'll pull in this question and quickly solve. It's a very simple questions. I'm really sorry for that, but we have to solve all of them. We are currently below 1300 rating value questions. So we'll solve this difficulty level 2. Okay, so this is difficulty level 1 questions. After like a bunch of after like bit C++, we'll have some interesting questions here. For level 2 and level 3, we'll quickly solve all these 100 by next week, I guess. Let me enter my username as well. The good thing about this site is, I'll also mention this in my here so that you guys can solve it. Wait, let me mention it below my handle. mm, System text is this. mm, I think it's better to mention description also. Let's see, I'll add it later. This is the site. You can Google A2OJ ladders directly and you get the first result itself. Oh, why is this? Oh, okay. Wait. So it was inverting the text. Yeah. Mm-hmm. Nobody's going to visit my handle, so I think it's better to minimize it. Here, A2J. This is weird, man. Okay, cool. So these are all the nearly lucky number we have pulled in. We'll take the x equal to input. We'll maintain a counter of 0 for I in x if I is 7 or 4. CTR equal to CTR plus 1. Hey, will this work? I'm not sure. Print CTR. If CTR is 7 or 4, print yes, else print no. Will this work? If this works, then Python is great, man. No, it won't. Or I is 4. For is, I think, is related to the type checking, I guess. I'm not sure whether it will work for the values because this is a constant, right? These both of them are primitive data types, and is, I think, is only works for abstract data types like list and everything, because is will basically check whether what type of class it belongs to. All the abstract data types are basically class, right, or object oriented programming related shit. So I think that's what is used is used. So we'll have to check for checking the value like this primitive data types and all. We'll use the actual the conditional operator, uh, whatever. So all of them are obviously working fine. I'll go here, select this solution, submit. Yeah, let's move on to the next question. So stones on the table. There are n stones on the table in a row. Each of them can be red, green, blue. Count the minimum number of stones to take from the rest so that any neighboring stones are different colors. What? Mm, there are n stones on the table in a row. Each of them can be red, green, blue. Count the minimum number of stones to take from the table so that any two neighboring stones can be different color. Stones in a row are considered neighboring if there are no other stones between them. Mm. Count the minimum number of taken so that any two neighboring stones are different colors. Here we take R. They're basically asking for how many characters are repeated. So in this case, one number is repeated. In this case, what? Okay, So what we can do is, if there are pairs of number, we'll simply have a counter when we have like pairs, right? Here in this case we have one pair, we'll increment 1, go to the next pointer and check for the next pair. If it's there, we'll increment the counter, next pair. So basically what they're doing is, if we have a neighboring next neighboring stone similar to the current one, um, we'll remove that, right? So that we, for the next okay, wait, I'm confusing. Let me just quickly pull in the question, select this as Python. So basically what the question is, they are asking us to remove the neighboring one. So these are neighbors, right? We'll start from R, the next one is the neighbor. So if they are same ones, if we remove the neighbor, next one will be unique, right? So that's what they are asking. So how many neighbors do we remove so that we get a unique this thing? So in the first case, RRG, when we are iterating from the first character, first index, we'll see that we have a similar one. We'll eliminate this one and go to the next one. We see that these are, we no longer have any neighboring this thing. No, wait, but in that way we have like RGG. How do we solve this? G. We'll only check if the neighbors are there. R. Remove this one, unique. If it's not equal, then we'll come here. We remove this. Oh, then it's no longer unique. We'll have to remove this also. Abe, wait. This is a weird ass question, man. Wait. Um, hmm, Weird question. Minimum number of stones to take from the table so that any two neighbor stones have different color. Stones in a row are considered neighboring if there are no stones between them. There are no other stones within them. Each of them can be red, green over the count the number of stones to take from the table so that any two neighboring stones are different. Next line contains convenience which represents color of the stone. We will consider the stones in a row number from 1 to n. And after write the ith character as equals r. Ith stone is red. Okay. Single integer and the answer to the problem. Okay. Stones in a row are considered neighboring if there are no count the number of minimum number of take from the table so that each number colors. In this case we'll remove the middle one. How do we determine that R? We should remove R. In this case nothing. In this case we have middle one. No, I'm wondering if, see, if it's a R, G, R, G and G, right? This case we won't remove any of this, but we remove this. And what if this is R, right? Oh, then it's already this thing, right? What if it's a G? We simply remove this one. Okay, so now, okay, what if it's a B, R, B, B? Oh, then we simply remove this one. Oh, B, 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 G, G. What if it was like this? So in that case, we simply remove this one. Count. We'll go for next one. This we remove this. If this is like this, so we don't have to remove this B, right? Uh, okay, cool. It's a straightforward problem. I think I was overthinking about the problem. That's why. Anyways, we'll start with this thing. So n equal to int of n, x equal to string. We'll simply go and check if there are unicorns. If there is a neighboring one, simply skip that number of skips is skip in the sense if we go RRG, right? For the first character we will do this. If we have similar character, we simply skip this character, which means we are removing that stone. We'll go to the next character and likewise for I in range of len of n minus 1. Oh, instead of this we'll go for while I equal to 0. That way it's very easy to increment I direct twice, right? That way it's mm, n x of x of I equal to x of I plus 1 counter x ctr equal to 0 ctr equal to ctr plus 1 and we come simply increment the counter and no, normally we'll increment the counter. We'll go to the next one and stuff like that and let's see expected one. Let's see what okay we're not printing out ctr int of input. Yeah, what? No, what the fuck? What did I type? This is 4. This is this past. Okay, this one is failed. 2. Received 2. This is ones where I skipped this once. Comparing this twice. We go here and directly. Oh my. Instead of skipping, what if we just maintain an increment, right? Maintain a counter. Yeah, we just maintain a counter and check how many neighboring, how many pairs we have unique values. Mm, no, but okay, let's see. If we already have a number, we remove this one. Then we don't have to remove. Okay, let's see. I'll simply submit this question. I think I'm overthinking this problem. That's what it is. Hmm. Successfully. What is the time and space complexity though? Oh, okay, it's accepted. Lol. What's the time and space complexity? N is 50 and O of n is 50 within 50, which means it's fine. We'll reload this thing. See that it's a green. Okay, cool. Panoma what? Panoramics prediction. The prime number is a number which has exactly two distinct divisors, one and itself. 273 are prime, 164 are not prime. The next prime number x is the smallest prime number greater than x. For example, the next prime number after 2 is 3 and the next prime number is after 3 is 5. Note that there is exactly one next prime number after each other, so 5 is not the next prime number of 2. Cool. One cold April morning, Panoramics predicted. Damn, man, cool name. Predicted that soon cacophonics will kick ass names, man. They're gamers or what? Anyways, cacophonics will break free from his Straight jacket. What does this mean? Is that a jail or what? Garment, long sleeves that are tied to the conflict. Oh, this is that Houdini wala shit. Yeah, see? Straight jacket. Damn. Then this will be a black day for the residents of Cali countryside. Panomerics prophecy tells that if someday Asterix and Obelix beat exactly X Roman soldiers were exiled by the next day that they beat exactly Y Roman soldiers where Y is the next prime number after X. Then it's time to wait for Armageddon, for nothing can shut shut up when releasing his. So whoa, this is some Game of Thrones shit, bro. Yesterday the Gauls bit. Yeah. Yeah, just checking whether it's a the both the numbers. This is the prime number. This is the next prime number or not. Oh my man, how do we check if the next number is the next prime number after this? Hmm. Okay, cool. What we'll do is we'll okay, first of all pull in the question. Select. Oh shit.